Between 2015 and 2018, South Africa's Western Cape experienced its worst drought on record. Cape Town's water supply dams dropped to extreme low levels and temperatures soared. But as the city grappled with securing drinking water for its population of nearly 4 million people, the unique freshwater fishes inhabiting the rivers that feed these dams also began to feel the heat. The Western Cape is especially vulnerable to the rising temperatures and reduced rainfall that global climate change models predict. And so, in 2014, the Freshwater Research Centre embarked on a study to investigate how these threatened freshwater fishes are likely to respond to a warmer and drier climate.
I think with climate change, people are saying, well, you might have to wait 50 years to see some change. And with this severe drought that we're experiencing, I think we're seeing into what climate change, what the Western Cape could be like in 20, 30 years' time. To actually see within a 3-year period, from a time when Tewaterskloof Dam was probably 80-90% full, to now where it's 10% full. To actually see as well in the rivers changes in fish communities over a 3-year period. You would expect it to be a much longer time, but I think these smaller streams are actually very sensitive, particularly to changes in flow and changes in water temperature. And we've seen changes just in looking at this pool in the Mandels.
The drought provided us a glimpse into conditions expected to become a lot more common in the decades ahead. During the course of our study, we used a combination of field surveys, thermal experiments, and predictive modeling to gain insights into how climate change might affect the fishes and their river habitats.
We're quite fortunate in the Western Cape to have this suite of highly endemic freshwater fish species, and they're super special. And one of the biggest challenges in studying these fish is the fact that most of them are highly endangered or endangered. And so there are these small populations that are just clinging on to survival. And to be able to work with these fish is really a privilege, and to be able to see them when we know that maybe our children will not have that opportunity is a really big privilege.
A lot of the rivers, parts of the rivers, the middle and low reaches, have almost been lost to these species because of invasive fishes, as well as huge level water abstraction from the river and increasing levels now of water pollution. So we're finding the native fish in the upper reaches of rivers, but with these very low flows, there's not a lot of habitat for them.
At the moment, we are at the Teerkloof River and we are looking at the Pseudobarbus skeltoni, which is the giant redfin, and we're seeing that there are certain factors that influence the distribution of this species. So factors like depth, flow, temperature, they're really going to come into play with climate change.
The redfins seem to need quite a bit of depth with complex habitat for you to find lots of them. So, I think going forward it's vitally important that we look after these refuge pools that have depth.
So the extinction threat is quite high for some of these fishes, and I think that it's quite important that we conserve them as best as we can.
The research team ran a series of thermal experiments to try to understand how the different fish species might respond to climate warming.
We catch fish in streams around the Cape Peninsula, take them back to the lab where we do the critical thermal maximum experiments on them.
We put the fish in a hot water bath that elevates temperature, and basically at what they call the critical thermal maximum, when the fish lose their writing response, we record the temperature, and generally the range is shown between 30 and 33 degrees Celsius.
The results so far reveal a wide range of thermal sensitivities, with the more sensitive species expected to be hit the hardest as the Cape's rivers warm.
Modelling is just a tool within the scientists' toolbox to take specific data and make generalizations. So it paints a picture of where the species either does occur or where it's likely to occur. For example, if we take a species such as the Breda River redfin, which is iconic of Western Cape rivers, it's also endemic to these rivers, and we look at current and future distribution patterns. Current patterns show already a fragmented distribution pattern. If we take away 20% of the flow, we notice a range contraction, which is quite marked. And if we run that with a 2-degree increase in air temperatures, that has a significantly negative impact on its distribution. Taking the two together would indicate that the species is likely to become extinct under fairly conservative climate change scenarios.
In the face of change and uncertainty, one thing is becoming abundantly clear. Balancing water for people and the environment is about to become a whole lot more complex. Our surveys show habitat being lost in the wild. Our experiments reveal how sensitive some of our indigenous fish are to high temperatures and reduced flows. And our distribution models warn of the risk of species extinctions as soon as this century. Now, the challenge is to bring these findings to managers and decision makers. Only coordinated action from government, policymakers, and civil society will ensure that these freshwater fishes remain a part of the Western Cape's rivers for many decades to come.